These notes are 2.3 on parallel and perpendicular lines. So the first question asks us to find the slope of each line. The slope of line A, and A is this guy right here. We want to find 2 points that land exactly on this line and then just count. Remember, your slope is your rise over your run. And your rise, if it's positive, that means your line is going up to the right. If it's negative, that means you're going down to the right, or you're falling. Your run, I always count that as the horizontal movement to the right. So if we pick 2 points, let's just pick this point and this point, we can see that we are rising 1 unit and we are running 2 units. So the slope of this first line is 1/2. Let's take a look at B. And we can see that B has the same slantiness as line A. If I pick any 2 points on line B, this guy and this guy down here, I can see that I'm going rising 1, running 2. So when lines have the same slope, they are parallel. Now let's take a look at line B. Oops, I wrote that in the wrong spot. Let me fix that. Okay, now we're looking at line C. Line C is this guy. And again, pick any 2 points, one to the left and one to the right. We always start furthest left to furthest right. Okay, from this point to this point, we are rising 2, running 1. So our rise is up 2, and we're moving to the right 1. And we can just leave that as 2. And then the last one, line D, that's this guy right here. Let's pick any 2 points. I'm just going to pick this guy and this guy over here. This time we are from left to right. We always read these left to right. We are rising a -2, or we are falling, and we are running 1. So this is falling 2, running 1. So falling 2, running 1, or just -2. Okay, so now let's look at perpendicular lines. We know perpendicular lines intersect at a right angle. These intersect at a 90-degree, a right angle. Okay, so perpendicular lines would be like line D and line A. Right here, we can draw in our right angle. So we said that line D has a slope of -2/1, or just -2. And the slope on line A was a positive 1/2. Well, how do these two numbers compare? We have a -2/1 compared to a positive 1/2. And hopefully you can see that these are going to be opposite reciprocals. So we flip and we change the sign. Opposite reciprocals. Opposite meaning one is positive and one is negative. That's what opposite means. And reciprocal means you flip. Okay, so given the slope 2/3, we need a parallel slope. Well, it's going to be the same. Perpendicular slope, we flip and we change the sign, -3/2. Remember, in all whole numbers have a 1 in the denominator, so I can rewrite this as -4/1. A parallel slope is just going to be the same. Or we could just, -4 is fine. A perpendicular slope, we want the opposite, so we know it's going to be positive, and we want to reciprocate, so we want to flip it, 1/4. All right, so a parallel slope is -1/4. A perpendicular slope, +4/1, or +4. Given the slope is 2, parallel slope would be 2, perpendicular slope, negative, and flip. Remember again, this is the same thing as 2/1, so we flip it and that's -1/2. So lines that are parallel have slopes that are the same, and perpendicular, opposite reciprocals. So if we're going to determine if the lines are parallel, perpendicular, or neither, first we need to identify the slope. So you've got to put it into this format, y equals mx plus b, because in this format we can identify the slope. In problem number 1, this is in the format that we're looking for. And we can see that the coefficient of x, the number in front of the x, is this guy. So we're comparing -1/2 and +2. Well, we can see that these are opposites and reciprocals, so these are perpendicular. In number 2, we're looking at these guys. These are opposites, but they're not reciprocals, so this is a neither. And in number 3, we can see that these are exactly the same, so these are parallel. In problem number 4, we want to write the equation of a line in slope-intercept form that passes through the given point and is parallel to the graph of the given equation. So slope-intercept form, that's y equals mx plus b. We're given a point. In this case, we've got 4, 9, so I'm just going to label this x1, y1. And we want to be parallel. Parallel equals the same. So first thing we need to do is solve for y, because it needs to be in slope-intercept form to identify our slope. So here's the term with the y, and this is what we did yesterday. We're going to get the y by itself. We're going to take away the 5x on both sides. On the right, we have a minus 5x positive 8, and then we're going to divide everything by the -2. So I have y is equal to a negative over a negative is a positive. Positive over a negative is a negative. Here's my slope that I'm looking for, 5/2. So I have a point and a slope. Let's use point slope. Y minus y1 equals m x minus x1. This is the best formula to use. So if I write it, y minus the first y is equal to the, see if we can jump right back in. Aw, it disappeared. So let's jump right back in. Let's see, we know our slope is 5/2. We have our point. Don't know what happened to that, but we can fix it. Y minus 9 is equal to m x minus 4. And if we combine our like terms, 5/2 x, 5/2, little scratch work here, times a -4/1, give you a -20/2, which is -10. When you're multiplying fractions, you multiply straight across. So then this is going to be -10. Add 9 on both sides. Y is equal to 5/2 x minus 1. This is our equation in slope-intercept form that passes through the given point and is parallel. All right, number 5. This time we want, again, slope-intercept form, so that's y equals mx plus b. And this time that we want perpendicular, and this is your symbol for perpendicular. It's like an upside-down T. We need opposite reciprocals. So first, we're going to solve for y to find out our slope. Let's get this term by itself. We're going to add 2x to both sides. We do the opposite, so they cancel. 3y is equal to 2x minus 15. Divide everything by 3. And y is equal to 2/3 x minus 5. This is what we're looking for. This is our slope. Our slope is 2/3. Now we have our point, x1, y1, which is 8, -5, and we plug it into our formula. Y minus y1 is equal to mx minus x1. So y minus a -5 is equal to 2/3 x minus 8. Let's go ahead and clean this up a bit. Let's distribute. So that's 2/3 x, a little scratch work on the side. 2/3 times a -8/1, multiply straight across, gives you -16/3. Okay, let's go ahead and subtract 5 on both sides. Okay, we're going to have to get a common denominator. If I'm going to subtract 16 over 3, negative 16 over 3 minus 5 over 1, I need to have a common denominator, and my common denominator is 3. So I multiply the second fraction by 3 over 3. That's going to give me negative 16 over 3 minus 15 over 3, which is negative 31 over 3. And it's okay to have a fraction. There's the equation. Oh, except for, what did I do wrong? I didn't find the perpendicular. Let's go back. I did not find the perpendicular. So let's flip this. Hopefully, maybe you saw that mistake and you're like, Miss Lozano, what are you doing wrong? All right, let's go back. I am not perfect by far. So let's try that again. Let's make sure I have it set up correctly this time. All right, y minus y1 equals the perpendicular slope. Remember, flip and change the sign. I want the opposite reciprocal, x minus 8. All right, so now let's go ahead and distribute. Okay, so that's negative 3 halves x. Okay, so I'm a little scratch work on the side. And my numerator is going to give me 24 over 2, and that is 12. Well, this one works out a little bit prettier at least. And subtract 5 on both sides. Y is equal to negative 3 halves x plus 7. Make sure you're reading the problem and answering what it's asking. It wanted the perpendicular slope, so I went back and reworked it. In the last little set of problems, it wants you to determine which lines are parallel. Before we can identify, you have to solve for y, because in this format is going to identify the slope. Parallel means the same slope. So before I can do anything, I've got to solve for y. In the first problem, I need to get the 2y by itself. I'm going to take away the x. And then I'm going to divide everything by 2. Okay, so now when you don't have a number in front, it's an understood 1. So this is really negative half x plus 9 halves. So I can see my slope is negative half. In this middle problem, I can see the slope is positive half. 0.5 is the same thing as positive. And let's look at the last problem. Let's get the y by itself. So I'm going to add x to both sides. Divide everything by 2. And again, if you don't have a number in front, there's an understood 1. So this is half x minus 5 half. My slope is half. So if I want parallel, I want the same. So which lines are parallel? This guy and this guy are parallel. They have the same slope.